Example 5. The following table shows the balance of an account at the end of each month. A. Determine whether the balance is increasing, decreasing, or constant. B. Determine whether the growth rate is positive, negative, or zero. And then C. Determine whether the growth rate is increasing, decreasing, or constant. Notice how the balance is going from $800 to $400 to $200 to $100. Certainly, the balance is decreasing as time goes by. If you trace the graph of balance over time from left to right, your pencil would always be moving downward. Because the graph is decreasing, we know that the growth rate is negative. In order to determine whether the growth rate is increasing, decreasing, or constant, let's examine this table a little bit further. The additional markings on the table show that as time increases from month to month, the balance decreases. Notice as we increase in time, the balance decreases, but the amount the balance is decreasing by gets less and less. The average growth rate from month 1 to month 2 is negative $400 per month. The average growth rate from month 2 to month 3 is negative $200 per month. The average growth rate from month 3 to month 4 is negative $100 per month. Thus, the magnitude of the growth rate is going from $400 to $200 to $100. This indicates that the magnitude of the growth rate is decreasing. Let's look at the second table. Notice, like the example above, the balance is decreasing from month to month. Because balance is our dependent variable and time is our independent variable, this means that the graph itself is decreasing. Thus, the growth rate is negative. So far, our answers to part A and B match the answers to part A and B in the first table. To answer part C, let's examine this table a little more closely. The balance is decreasing by $100 from month 1 to month 2, $200 from month 2 to month 3, and $400 from month 3 to month 4. Since the balance is decreasing, the growth rate is indeed negative. From month 1 to month 2, our growth rate is negative $100 per month. From month 2 to month 3, our growth rate is negative $200 per month. And from month 3 to month 4, our growth rate is negative $400 per month. This means the growth rate is increasing in magnitude. That is, just because the balance is decreasing does not mean the growth rate is also decreasing. Although in the example above, both the balance and the growth rate were decreasing. To help keep track of what all this means, let's look at the summary below. In summary, the growth rate of data is reflected in the steepness of the graph. Steeper graphs indicate a growth rate of greater magnitude. An increasing graph indicates a positive growth rate, and a decreasing graph indicates a negative growth rate. Here are some examples of graphs that are increasing and have positive growth rates. Notice on all these graphs, if we trace them with a pencil from left to right, our pencil would go upward. Therefore, the graphs are increasing. Because the graphs are increasing, the growth rates are positive. Now let's consider graphs that are decreasing and therefore have negative growth rates. Notice if we trace these graphs with pencils from left to right, our pencil would move downward. Next, a graph that is constant necessarily has a growth rate that is 0. Here's an example. Notice if we trace this graph with a pencil from left to right, our pencil does not move up or down. We are looking at a graph whose function value always equals one number. That is, it's a constant. And because there's no change, the growth rate is 0. Next, let's look at graphs that are getting steeper. Because these graphs will be getting steeper, their growth rates will be increasing in magnitude. As we move our pencil from left to right, the graph goes from being very flat to very steep. Similarly, as I trace the second graph from left to right, the graph goes from being almost completely flat to being very, very steep. Notice this first graph is increasing while the second graph is decreasing. Yet, both growth rates are increasing in magnitude because both graphs are getting steeper. Next, let's look at examples of graphs that are getting flatter and therefore have growth rates that are decreasing in magnitude. As I trace these two graphs from left to right, you will notice that they go from being very steep to very, very flat. The fact that these graphs get flatter as we go from left to right means that the growth rate is decreasing in magnitude. Note, if they were to get perfectly flat, like this graph up here, the growth rate would be 0. Also, note that the graph on the left is increasing while the graph on the right is decreasing. So it is possible to have both an increasing graph and a decreasing graph with growth rates that are decreasing in magnitude.